Welcome to 5.6, the last section in Chapter 5. Woohoo! We are moving along. And in fact, you will see that this section is rather short and simple. Short and sweet. Inequalities, greater than or less than. That's what you think of when you see inequalities in two triangles and indirect proof. So our objective is, or our essential question, how can I use inequalities to make comparisons in two triangles? That's what we're talking about, comparing different triangles and seeing which one is the lesser angle or the smaller length of side. So we have this hinge theorem, and what are they talking about when they are referring to a hinge? Well, they're thinking about like on a gate here. Here's your hinge, and as you swing the gate open, the distance from the end of the gate to the door post there will increase as you open that thing up and make this gate wider and wider. Of course, the distance from the end post here and the end of the gate is going to be larger so that you can walk through. Well, that just kind of makes sense. So keep that same principle when you come over to this theorem, this statement of the theorem. And they're saying that if two sides of one triangle are congruent to two sides of another triangle. Okay, so here's one pair of sides that are congruent, and here's another pair of sides that are congruent. And the included angle, remember the angle that is between or formed by those two sides, of the first is larger than the included angle of the second. So here is the first, and they're saying that this included angle here, 88 degrees, is larger than the included angle of the other triangle, 35 degrees. 88 is greater than 35. Then, then the third side of the first is longer than the third side of the second. So this is the third side. This third side of this first triangle is longer than the third side of the second triangle. See what we're doing? So as long as we can get two pairs, well, as long as we have two pairs of congruent sides, and we're talking about the included angle between those two sides, then if that included angle is larger than the other one, then the third side will be longer than the other one. Just makes sense, doesn't it? So for example, here I have the green side and the blue side. Why do I get my colors mixed up? The green side and the blue side, and let's do it this way, as I open up and make this included angle between these two larger, well, of course, the distance between these two is going to be larger. As I make that included angle smaller, then the third side, or the distance between those two, is going to get smaller and smaller. That's all that we are talking about. Here is the converse of that. Remember Converse? Think of a guy wearing Converse sneakers and they're switched. So what we said before is that if the included angle is bigger, then the third side will be bigger. Now we're saying the converse of that, which is if the third side is bigger, then the included angle will be bigger. So that's why I've drawn these arrows here. Connect the angle with the side across from it. Remember how we did that back in section 5.5? And if the angle is bigger, then the side across from it will also be bigger. If the angle is smaller, then the side across from it will also be smaller. Or if the side is smaller, then the angle across from it will be smaller. So connect those the angle and the side across from it. Connect those together when you are comparing triangles. That's it. That's all it is. Let's do some examples. Make sure this solidifies in your mind. So here, for example, we have a triangle on the left-hand side, and we have a triangle on the right-hand side. And they are wanting us to compare. Let me just do this. Let's do 1 and 2. We want to compare angle 1 with angle 2. So which angle is bigger? Which angle is bigger? Well, we remember, we need to have two pairs of congruent sides to compare the triangles. Well, I do have one pair of congruent sides here, but where's the third pair? Well, it's this one. Okay, dude. See, this side right here for the left triangle is the same side for this right triangle. And so therefore, by reflexive, this side for the left triangle is congruent to this side for the right triangle. So in other words, think of it this way. Here's my blue and my green, and here's my blue and my green. Probably can't see all this in the video, but the blue is the same side that we're talking about here. Okay? And so, therefore, this is the included angle between those two pair of congruent sides. And let's look to see the opposite side and compare those, because we do have that length. And here, the 24 is bigger than the 23, so therefore angle 2 will be bigger than angle 1. Makes sense? Look for the bigger side, and that will be across from the bigger angle. Here is the smaller side, and that is across from the smaller angle. Here's another example. They explain these two groups of mountain bikers start the camp and they head out in opposite directions. They both go 2 miles. And then this one group on the right-hand side, Group A, they do a 45-degree angle turn and they go 1.2 miles. Whereas this other group, Group B, they do a 30-degree turn and go 1.2 miles. And now the question is, which of these group of mountain bikers are farther away from the camp? Okay, so let's do this geometrically. And what do we have here? We have two triangles, and obviously they are not congruent with each other. And we do have, here's one pair of sides that are congruent, and here is another pair of sides that are congruent. So remember, it needs to be the included angle between those two pair of sides. So I need to figure out this angle here. They told me that this exterior angle was 45 degrees, and of course it's supplementary with the adjacent interior angle. So 180 minus 45 gives us 135. Same kind of principle over here. The exterior angle for this triangle is 30 degrees. So therefore 180 minus 30 gives us 150. So now I can compare these included angles. And this included angle is larger, or bigger, let's say it that way, is bigger than the other one. Therefore the side, the opposite side, is going to be bigger than in the other triangle. So Group B has traveled farther from the camp. Okay, now there is a section here on your notes. Well, hold on. You are now ready to do this, and you can do this on your own. But before you go, there's a section in your notes about the indirect proof, and we could talk about that, but that is not going to be on the midterm exam coming up, so I'm going to skip over it. Did you hear that? I'm going to skip over it and not do indirect proof. Okay, so as long as you don't tell anyone that we're not going to do this, it will not harm you. It's not something that will be on the test. So we're just going to skip over it. As long as you don't tell anyone, please don't make a video and like put it up on YouTube or something telling other people, but let's just skip over that. So you just focus on this, these problems here with the theorems that we talked about. You should be able to do these without much problem. And what we're looking for between these two is either the greater than sign or the less than sign. That's what you want to plug in to these little blanks here, as it talks about up there. Or we could put the equal sign. I guess that's another option. Okay, hope that was helpful to you, and I look forward to seeing you in class. May the Lord bless you.